Welcome all to YouTube channel Mechanical Study, where we study different mechanical systems. Today we are going to continue with our thermodynamics series. We already covered question 121 questions. So we'll start with the question number 122. So this is the thermodynamics subject. This subject will be helpful for you to understand the concepts of thermodynamics, and along with that, whatever the questions that may comes in various competitive exams like SSC JE, GATE, then engineering service exam and various uh, state exams. So watch video till the end. So we'll start with the question number 122. Consider the following devices. First, internal combustion engine working on Otto cycle. Then next, internal combustion engine working on diesel cycle, gas turbines, steam turbines. In which of the above devices the equation del Q is equal to du plus Pdv is not applicable? So this is the equation that is for the closed system, that is nothing but del Q minus del W is equal to delta U, or you can write out it as a del Q is equal to du plus P du. Instead of del W you can also write it as a dP dV. So here this is equation that is applicable for closed systems. So here considering the fact that for the above equations, so here, so this equation can be, now here the question is not applicable. So here gas turbines and steam turbines, those can be considered as open systems. Okay, that means it will cross the mass as well as energy crosses the boundary of a system. So here this can be considered as open systems, and here this equation will not be applicable to such two devices, that is gas turbines and steam turbines. So option C will be the right answer. So gas turbines and steam turbines are both where this equation will not be applicable. Now internal combustion engine working on Otto cycle, then internal combustion engine working on diesel cycle. So here we consider that this has to be a closed system. This has to be a closed system where a Otto cycle is can be drawn on PV diagram, where it is also called as a constant volume cycle. Such cycle will be drawn on PV diagram for a Otto cycle. Similarly, diesel cycle can be drawn like that. It is a constant pressure cycle, so it can be drawn like such. Okay, so it is considered that it is to be closed system. So here, whatever the area under the curve on a PV diagram will give a net work done, that is W net, for both the cases. So this is all about for Otto cycle and diesel cycle. Otto cycle, which is also called as constant volume cycle, diesel cycle, which is also called as constant pressure cycle, because heat addition takes place at constant volume in Otto cycle and at constant pressure in a diesel cycle. So here we can consider that is the equation del Q is equal to du plus Pd, that is not applicable for gas turbines and steam turbines. The next question, the steady flow energy equation of a perfect gas flowing through a nozzle with the initial and final velocities of V1 and V2 are given by. So I'll just write down the steady flow energy equation on unit mass basis. So it comes out to be H1 plus V1 square by 2 plus Z1 plus Q will be equals to H2 plus V2 square by 2 plus Z2 plus W. Now here, suppose I am considering an open system through which a fluid is flowing, and I am considering its head, that is determined, that is Z1. Then here I am considering this as a Z2. This is velocity at outlet, this is velocity at inlet, enthalpy at inlet, enthalpy at outlet. There is also heat and work interaction takes place with the closed system. As this is open system, so there will be a mass as well as work or a heat transfer takes place from the system. So here consider the fact for the, so you have to derive this equation or simplify this equation for the nozzle. So nozzle is a device where pressure energy gets converted into kinetic energy. Okay, so nozzle, basic function of nozzle is to increase the velocity. Okay, is to increase the velocity of a fluid. So here there will be no transfer to the surrounding, that means heat transfer is 0, and there will be no work performed by the system, so work transfer also 0. So here final equations comes out to be that is h1 plus v1 square by 2. Here data made is also constant, so its differences will be 0. So this will be equals to h2 plus v2 square by 2. So here h1 minus h2 can be written as v2 square minus v2 square minus v1 square by 2. So in option B you can see the correct answer, that is option B will be the right answer. Then question number 124, heat transfer in a cyclic process R plus 20 kilojoule minus 5 kilojoule, then minus 10 kilojoule and plus 15 kilojoule. The net work done for cycle will be given by. So here net work done will be given by. So for that purpose we have to use a simple, that is for any closed system that is undergoing a or executes the cycle, then del Q will be equals to, that is cycling integral del Q will be equals to cycle integral del W. So that is the summation of all the heat transfer will be equals to sum of all the work done. So here the equation comes out to be, that is sum of all those things will give the net work done. So here 20 minus 5 minus 10 plus 15, so 20 plus 15 35 minus 15, so it will be all comes out to be plus 20 kilojoule. So net work done will be 20 kilojoule. It is positive, that means work done by the system onto the surrounding. So here plus 20, that is option C will be the right answer. The next question, 1 kg liquid with specific heat of 3 kilojoule per kg Kelvin is stirred in a closed chamber and its temperature is raised by 10 degrees Celsius. Heat loss to the surrounding is 3 kilojoule. Work done on the water during the process will be. So here we can see a diagram, that is the stirrer is used to stir the water in a or liquid that is present in a closed chamber, and here work will be done onto the whatever the liquid that is present in the chamber. So here work input that we have to find out. Okay, work done on the water that we have to find out. So whatever the work done on the water, that will be equals to the heat, that is the temperature rise, or that is the here a change in internal energy of a gas, that is a change in internal energy of a liquid that is present in the chamber plus the heat transfer to the surrounding. Here the change in internal energy can be taken as MCV dt, and heat transfer to surrounding, that is 3 kilojoule. So here mass is nothing but 1, specific heat is 3, and temperature changes, so here 10 plus 3, so it is 30 plus 3, 33 kilojoule. So the net amount of work that is done by the stirrer onto the water will be the 33 kilojoule. So option D will be the right answer for the given question. Then question number 126, a system is composed of gas contained in a cylinder fitted with a piston. The gas expands from state 1, for which that is internal energy equals to 75 kilojoule, to a state 2 for which internal energy is minus 25 kilojoule. During the expansion, gas does 60 kilojoule of work on the surrounding, so it is positive. The heat transfer to or from the system during. Okay, so here you have to use the formula, that is Q minus W will be equals to delta U. Here we have to find out the Q. So here Q minus work done will be the positive, that is minus 60. It remains same. Internal energy changes minus 25 minus 75. So it is comes out to be Q minus 60 will be equals to minus 100. So Q will be equals to minus 100 plus 60, it is equals to minus 40 kilojoule. So it will be the minus sign. So this negative sign indicates that it is transferred from system to the surrounding. So here minus 40, that is option B will be the right answer. The next question, for a heat engine cycle, which of the following relation is always true regarding heat transfer and W, that is work transfer. So here for a heat engine cycle, so here you are considering it to be a closed system, and if it is executes a cycle, then that is the cyclic interval of del Q will be equals to del W. So option B will be the right answer. So that is the summation of all the heat transfer during the process will be equals to sum of del W. So here option B will be the right answer. Flow work is analogous to. So here flow work, this is also represented by P dV. That is for the non-flow process which is carried out in a closed system, and for flow process it is V minus V dP. So here flow work, which is also called as displacement work. So option C will be the right answer. If H be the heat supplied to the system to do work W and change in internal energy as delta U, then questions is H is the heat supplied to the system to do work W and change in internal energy as du, then here you have to simply use the formula, that is Q minus W is equal to delta U. So instead of Q here would be, we have to put H, because H be the heat supplied to the system to do work W and change in internal energy delta U. So H will be equals to delta U plus W. So it is given in option number, that is A. So here option A will be the right answer. Then next question, if del Q is the heat transfer to the system and del W is the work done by the system, then which of the following is an exact differential? So first of all we must know the what is exact differential and inexact differential. So whatever the system properties of a system, so that is pressure, then temperature, enthalpy, entropy, all are exact differentials, and that is a those are the path functions, or not a properties of a system like heat and work, all are the inexact differentials. So here, so one can write down that is for the del Q is nothing but it is a path function, so it is not a exact differential. Again del W is also not a exact differential. Then summation of del Q plus del W, from that we will get not any definite property of a system, so it is not also a exact differential. But lastly, that is del Q minus del W, from the first law of thermodynamics, that is del Q minus del W is equal to delta U. So it gives us a property of a system. See here, that is del Q minus del W will be the equals to delta U, and that is a property of a system, that is internal energy is a property of a system. So here delta U can be written as U2 minus E1, and that is the exact differential. So here option D will be the right answer for question number 130. And next question, that is question number 131. An elastic generator coupled with a windmill produces an average electric power of 6 kilowatt. So here power is used to charge a storage battery. So the storage battery, heat transfer from the battery to the surroundings is 0.3 kilowatt. What will be the amount of energy stored in the battery in 2 hours? So for here, again you have to use a simple, that is Q minus W is equal to delta U. Now here the work done, that is electric power. Okay, so here this much of the work will be done in order to charge the battery. So here input will be 6 kilowatt. 6 kilowatt work will be done from by the surrounding onto the system, so it is negative. Similarly, heat transfer, suppose I am considering this storage battery as a system. So here, in order to store energy in a battery, we need to give or done 6 kilowatt of work into on it. So it is the work done by surrounding onto the system. This is the battery considered as a system, out of which a 0.3 kilowatt of heat is transferred to the surrounding, so it is again negative. So here, that is Q, that is minus 0.3, then that is to the W, that is minus of minus 6 will be equals to delta U, and delta U is nothing but the change in internal energy, that is the energy that is in a storage. So it comes out to be plus 6 minus 0.3 is 5.7 kilowatt. So here the internal energy stored in the system will be 5.7 kilowatt. But here given is that we have to find out this, what will be the amount of energy stored in battery for in 2 hours. So for 2 hours duration, just we have to multiply this with the 5.7 with multiply by 2 into 3600. This is the energy, 5.7 kilojoule will be the, that is kilowatt is the power, it is the 5.7 kilojoule per second. So 5.7 kilojoule of energy will be stored per second. So here for 2 hours duration, we have to just multiply with the 2 into 3600. This will give us value, that is 41,040 kilojoules. So option D will be the right answer for the question. The next question, that is question number 132. Statement 1 is the energy of an isolated system is constant. So it is true, that is a delta U will be equals to 0 for a isolated system, because there will be no mass as well as energy interaction with the surrounding, and U remains constant for the isolated system. The next question, that entropy of an isolated system can increase but cannot decrease. So again that is a delta entropy change of a system plus entropy change of a surrounding is equals to entropy change of a universe. So here entropy of an isolated system can increase, so it is true, that is the entropy change of isolated system is increases, it cannot decreases, so it is a true statement. So here this can be both the statement, that is statement 1 and statement 2, both are correct. So here options are not given, but here both the options are correct. The statement 1 as well as statement 2 are correct. The next question, a system absorbs 100 kJ of as heat and does 60 kJ of work along path 1, 2, 3. So this is the path 1, 2, 3. Similarly, the same system does 20 kJ work along path 1, 4, 3. The heat absorbed during the path 1, 4, 3 is, that we have to find out. So for that purpose, we first of all find out the change in internal energy for path 1, 2, 3. Here Q is the heat absorbed is 100 kJ, that is positive. And if it does the work of 60 kJ, again it is positive, that is Q minus W will be equals to delta. So internal energy change is 40. So irrespective of any path, the change in internal energy will be remains same if the initial and final state, that is 1 and 3 are identical, then internal energy change will be 40. So here for process 143, here process 143, the work done is 20 kilojoules. The same system does work, so it is work done by the system, so it is positive. So Q minus 20 will be equals to delta U, which is 40. So here Q will be the 60 kilojoules. So here option, that is in option D given, that is 60 kilojoules. So option D will be the right answer for question number 133. The next question, during a constant pressure expansion of a gas, 33.3% heat is converted into work, while the temperature rises by 20 Kelvin. The specific heat of gas at constant pressure is proportion of work. So first of all, you must know the relation between heat and specific heat, that is Q is equal to mc dt. Okay, once you know that, we can easily solve. Here the relation is given, that is out of the total only 0.33 or 33.3% part of a heat is converted into work. So W will be equal to 0.33 Q. So here Q can be written as in terms of W. So Q can be here, that is W. We have to find out C in terms of, that is specific in terms of work. So this can be written as we know that the W is equal to 0.33 Q. So Q will be equals to W upon 0.33. This will be equals to Cp. When still the mass equals to 1 kg, then 20, that is the temperature rise. So W in terms of Cp will be equals to, or Cp will be equals to W upon 0.33 into 20, that is 6 upon 6.6. So it comes out to be 0.15 times W. So 15% will be the answer, that is option D will be the right answer. The next question number 135. A cylinder contains over 10 meter cube of an ideal gas at a pressure of 2 bar. This gas is compressed in a reversible isothermal process till its pressure increases to 15 bar. What quantum of work will be required for this process? So process is reversible isothermal process. So for reversible isothermal process, work done will be equals to PV ln of P1 by P2 or PV ln of P2 by V1. So here volume is not given, pressure is given at two states, that is for first condition it is 2 bar, and then at that is it increases up to 15 bar. So here values of pressure is given. So here work done can be written as, here initial pressure is 2 bar, so it is 2 into 10 raised to 5, volume is 10, then log to the base C of 2 upon 15. So if you solve this, you will get the final answer, that is minus 4029.8, that is approximately equals to 4030 with negative sign, that is work done onto the system by the surrounding. So here option B will be the right answer. The next question, during a certain compression process 1 kilojoule of mechanical work input is supplied to 2 kg of a gas enclosed in a cylinder piston assembly and 400 joule of heat is rejected to the cooling water being circulated in the jacket encasing the cylinder. Okay, this brings about a change in specific internal energy by. So here the question is that is the process is a compression process with 1 kilojoule of mechanical work input is supplied to 2 kg gas enclosed in a cylinder piston assembly. Okay, so considering the cylinder piston assembly where 2 kg of gas is enclosed and 400 joule of heat is rejected to the cooling water. So heat rejected, suppose I am considering this as a system, that is piston cylinder alignment, where so here heat rejected to system is 400 joule and 1 kilojoule of work is done, that is 1000 joule of work will be done onto the system. So here, so change in internal energy will be equals to 4, that is nothing but here, so it is work done, so it is minus sign, it should be a minus sign, and it rejects it, again it is also a minus sign, that is minus 400. So here delta U is equal to delta Q minus del Q minus del W. So here del Q is minus 1000, minus become plus, so it is comes out to minus 600 joule. That is the internal energy change, that is Q minus W, as Q is, sorry, it is reverse, that is work is 1 kilojoule and that is work is, here again I have solved it on screen so for a better understanding. Here work will be 1 kilojoule, so input is 1000 joule with negative sign because it is a work done onto the system, out of which 400 joule is rejected to the surrounding. So again it is negative because it is rejected from the system. So here that is del Q minus del W will be equals to delta U. So internal energy change will be equals to del Q is how much? It is minus 400. So minus become plus, that is 1000. So it is comes out to be 600 joule. Internal energy change will be 600 joule. But we have to find out specific internal energy change. So for that purpose we need to divide it by mass. So here mass is 2 kg. So here delta U upon mass will give us a specific, that is d small u or delta small u. So capital U is the internal energy, small u is the specific internal energy. So here per unit mass, so for that process it is 600 divided by, so it is comes out to be 300 joule per kg. So here 300 joule per kg is given in option C. So option C will be the right answer. The next question, that is question number 137. The internal energy of a certain system is function of a temperature alone and is given by formula E is equal to 25 plus 0.25 T, where T is the temperature. If this system executes a process for which the work done by it per degree temperature increases each, so work done per degree temperature changes, that is dW by dt is given, that is comes out to it is 0.79 kilo Newton meter per degree Celsius change, so per degree Celsius. So it is dW by dt is also given, where dW by dt is equal to Q minus W. The heat interaction per degree temperature increase in kilojoule each. So again E is given, so differentiate this equation with respect to T, we will get the dE by dt, that is comes out to be 0.25. Okay, then next that is the dW by dt is also given, del W by del T is also known to us, it is 0.75. Similarly del E upon dE upon dt, it is 0.25. So we have to find out Q only. This Q minus W is equal to delta U, per we have to find out with this differentiate with respect to. So for differentiating this, so here you will get del Q by dt minus del W by dt upon du by dt. So here du by dt is or a DE here, internal energy given in terms of E, so it is 0.25. So if you are taken this term on right side, it should be plus 0.75. So 0.75 plus 0.25, it is comes out to be 1 kilojoule. So option B will be the right answer. Then next question for today's lecture, that is a system undergoes a process in which heat transfer to system is 30 kilojoule and work done by the system is 35,000 Newton meter. The change in internal energy of the system. So again we have to use first law of thermodynamics, that is del Q is equal to du plus del W, or del Q minus del W is equal to du or delta U. It is taken also written as a delta U. So here heat transfer to the system, that is positive, it is 30 kilojoule. Similarly, the work done by the system, again it is a positive, and it is it is given in Newton meter, 35,000 Newton meter, that is 35,000 joule. So it is comes out to be 35 kilojoule. Newton meter is nothing but a joule, and 35,000 joule is nothing but 35 kilojoule. So here 30, that is the heat transfer, minus 35, so delta U change will be negative, and it is comes out to be minus 5, and that is given in option minus 5 kilojoule, that is given in option B. So here option B will be the right answer. Then last question for today's lecture. Sorry, a few questions also, not last question. We will try to solve up to question number 147, and in next lecture we will continue with the second law of thermodynamics. So it is not last question. Okay. Then question number 139. Air is compressed adiabatically in a steady flow process with negligible change in potential and kinetic energy. Work done in a process is given by. So air is compressed adiabatically, steady flow process. So it is done the process that is carried out in an open system here. So for that process work done in the process is nothing but minus V dP. Okay. So here one thing we should know, for a process, if you process that is takes place in a open system, that is there will be a mass as well as energy interaction with the surroundings. Suppose this is a process 1 to 2. So here this is a process, either compression or expansion process. Here whatever the on PV diagram, whatever the work done, we have to plot it on a pressure diagram, and it comes out to be minus of V dP. That is work done will be equals to minus of V dP. And if the process is carried out in a closed system, then in that case we have to plot it on a, that is on a volume diagram, and it is the this much area, and it comes out to be P dV, that is with the positive sign. So here this thing we must know. Okay, that is work done for a non-flow as well as for the steady flow processes. That is a steady flow, the process that is carried out in a open system, and the non-flow process that is carried out in a closed system. What is open system, closed system, as we have already discussed all those things. So here option C will be the right answer for the given question. The next question, for a non-flow constant pressure process, the heat exchange is equal to. So here is for a non-flow constant pressure process, that is a process that is carried out in a closed system, which is also called as a non-flow process. So here that must be equals to. So for that purpose you must know the two TDS relations, that is TDS is equal to du plus PdV, or TDS is equal to TH minus V dP. Here for a constant pressure process, if you use this equation, that is marked with the rectangle, here pressure is constant, so this term will be equals to, so here TDS will be equals to DH. And as you all know that the del Q by T is nothing but D. Yes, so here for a non-flow constant pressure process, here the heat transfer is nothing but equals to change in enthalpy. So option D will be the right answer. That is only for constant pressure process. If it is a constant volume process, that is volume is constant, then in that case the transfer will be equals to change in internal energy, and the relation between entropy change with respect with the transfer is nothing but ds will be equals to del Q by T, and del Q is nothing but ds into T. So here for constant pressure process, the heat transfer is will be equals to change in enthalpy of a system or enthalpy of a system. So option D will be the right answer. The next question, that is a piston cylinder device with air at initial temperature of 30 degrees Celsius undergoes the expansion process for which pressure and volume are related as given below. The work done by system with n is equal to 1.4 will be. So here n is given, where n is nothing but a polytropic index, and for polytropic process work done is nothing but P1 V1 minus P2 V2 upon n minus 1. But here three states are given, that is at state 1 it is 100, at state 2 the pressure is 37.9, and at state 3 it is 14.4. So here expansion process is carried out where pressure, as you all know that during expansion process pressure will decreases. So initially it is 100, and finally it is 14.4, and volume will increase 0.4 to 0.1 to 0.4. So here we have to use just the equation, that is 100 kilopascal into P1 V1 is nothing but 0.1 minus 14.4 into 0.4, that is the final volume, upon n minus 1, that is 1.4 minus 1, that is 0.4. So just we have to solve this, we will get the final answer, that is 10.6 kilojoules. So option D will be the right answer. Okay, the next question, a Carnot heat pump absorbs heat from atmosphere at 10 degrees Celsius and supplies it to a room maintained at 25 degrees Celsius. Temperature difference of 5 degrees Celsius exists between working fluid and the atmosphere on one hand and required room temperature on the other hand. Okay, so if the heat pump consumes 1 kilowatt power, the heat delivered to the room will be. So first of all I will tell you what is heat pump. So heat pump is a device which is basically used to heat up the room for the human comfort. Okay, so basically a heat pump is exactly opposite to a refrigerator. So here pump, here suppose I am considering this is a reservoir with a higher temperature, consider this as a T1, this is a reservoir at a temperature T2. Suppose pump is basically used for the purpose of heating of rooms. Okay, so here it's a COP, that is a power consuming device. So here this COP is nothing but the desired effect that we have to achieve on the higher temperature side T1, as if it is a reversible heat pump then, or a Carnot heat pump which is also called as a reversible heat pump. So for that condition it can be written as in terms of temperature. So it can be written as T1 upon T1 minus T2, or it can be written as, suppose this is Q1, that is it applied upon Q, this is the heat absorbed from the surrounding and power this is applied. So here this can be written as, that is Q1 upon Q1 minus Q2, or Q1 upon power supplied. So here just we have to put all those in equation of a COP. First of all, that is COP is nothing but T1 upon T1 minus T2. This is the T1 is the higher side temperature, T2 is the lower side temperature, or the COP is equal to Q1, that is heat supplied to the room, or desired effect to the power input, that is power required. So just we have to put in the final equation to get the right answer. So here here we can see on the screen the right option, but just tell me how it comes out to be in a comment box. So reply your answers in comment box. I'll be waiting for your answers. The next question, that is question number 143. Air is compressed isothermally by performing work equal to 16 kilojoule upon 8. The change in internal energy is, without any doubt, see the process is isothermal. Okay, so we don't have to see anything else. For isothermal process, we all know that the change in internal energy is 0, because internal energy is a function of temperature, and for isothermal process temperature is constant. So whatever the temperature change will be 0. Similarly, internal energy change is 0. So we don't have to see anything else. So for constant isothermal process or constant temperature process, change in internal energy is 0 irrespective of any work done, heat transfer. We don't have to consider all those things. So option B will be the right answer. The next question, a mixture of gases expands from 0.03 meter cube to 0.6 meter cube at constant pressure of 1 megapascal and absorbs 84 kilojoule of heat during the process. The change in internal energy of the mixture is, okay, very good. Here again, that is the we have to find out the change in internal energy of a mixture. But before that, we have to find out Q, then W, and finally we can find out the delta change in internal energy. So here to find out the work done, we have to use a formula that is P dV. So here pressure is 1 megapascal. So I will convert it into keep it in a megapascal. So it into change in volume, that is 0.06 delta V, that is V2 minus V1 minus 0.03. So it is comes out to be 0.03 in megapascal, that is in megapascal. So convert it into a, now here we have to megapascal, we have to convert it into a kilojoule, that is we have to find out the work done. Okay, so here for that purpose we should multiply with the 10 raised to 3 and it is comes out to be 30 kilojoule, that is the work done. See, it is not in megapascal because pressure is in, here it is in a megapascal and volume change is in meter cube. So if you simplify this, this will be comes out to be in kilojoule. If you multiply with this with the 10 raised to 3, it is not in megapascal. So if you simplify all those things, we will get the final answer, that is 30 kilojoule. That is the work done is 30 kilojoule. Okay. So then next question, next that is we have to find out the change in internal energy, and here heat absorbed is 84 kilojoule heat absorbed during the process. So here work done is that we already find out 30, that is 84 joule is absorbed, so it is a positive minus 30, that will give us delta U and it is comes out to be 54 kilojoule. So here option B will be the right answer. Then next question, a machine produces 10 kilojoule work by consuming 10 kilojoule heat. This machine will be. So for that purpose we must know the, that is the second law of thermodynamics. So perpetual motion machine of kind second, PMM second, are those machines where its input will be equals to output. That is the, if you supply 100 kilojoule of heat to the machine, that is perpetual motion machine of kind second, it will give us a 100 kilojoule of work output from the machine. But these machines violates the second law of thermodynamics, that is the Kelvin, either Kelvin Planck statement or a clause S statement. So basically where the machines where input is equal to the output, those machines are called as perpetual motion machine of kind second, and those violates, that is second law of thermodynamics. So basically here option B will be the right answer, where perpetual motion machine of kind second is nothing but the where input is equal to output. But according to thermodynamics second law, that is either Kelvin Planck statement or a clause statement, there will be some degradation of energy. That means we cannot convert heat into 100% work. You can convert work into 100% heat, but we cannot convert heat into 100% work. So here these are the machine, that is perpetual motion machine of kind second, are those machines, or that is the hypothetical machines, that are the machines that are not practically in use, or that is not designed, or that is not manufactured in reality. So these are the machines where we cannot convert, or those machines which can convert input into 100% output. But according to thermodynamics second law, it is not practically possible. That is the Kelvin Planck statements and clauses statements. Okay, so those machines which violates the clauses statement and Kelvin Planck statements are called as perpetual motion machine of kind second. So those are the hypothetical machines. So option B will be the right answer. Then next question, for a steady flow system where kinetic and potential energy are negligible, first law of thermodynamics can be expressed as. Okay, so for steady flow system, for that purpose we must know the equation, that is H1 plus V1 square by 2 plus Z1 plus Q will be equals to S2 plus V2 square by 2 plus Z2 plus W. Here neglecting the kinetic energy and potential energy change, so here these terms will be 0. So here for according to first law, that is Q dot, rate of heat transfer minus rate of work done will be equals to delta A, that is change in enthalpy for a steady flow system, that is a open system. So here option D will be the right answer. The next question, that will be the probably the last question for the today's lecture, that is the for a process value of cyclic integral of del q minus del w is. Okay, so that is for the process either cyclic integral. So it is a nothing but the here, that is a cyclic integral of del q minus del w is equal to nothing but a delta u, and for a process that is where its integration, that is this will be equals to delta u and this will be equals to 0 for a process here. So here option, that is a change in internal energy. Okay, so it is a property of a system. So here cyclic integration of system property will be 0. So according to that its value comes out to be 0 because it is a point function or property of a system, that is internal energy. It is difference of these two quantity, that is del q minus del w, and its cyclic integral will be comes out to be, as it is a property, so it is comes out to be 0. So here option C will be the right answer. So this is all for today. I hope you are enjoying our lectures series, and also do your valuable feedback in comment box, and also watch our the question bank series that we already upload on our YouTube channel, and also like to our YouTube channel, then subscribe to our YouTube channel, like to our videos, and share with your friends, those who are preparing for the different competitive exams like SSC JE, then GATE, and RRB JE, then various state exams. So this is all for today. I hope you have enjoyed it. So thank you for watching. Do like and subscribe to our channel. Thank you.